So I would basically specify move 5 steps, get to the next costume, and then I wanted to make another 5 steps. I would change the 10 to 5 here, and then change the costume again. Because this particular sprite has exactly 2 costumes. Now how do I know it has exactly 2 costumes? Because I can go to the switch to costume action, and it can specify up to 2 costumes, and that means for this sprite there are 2 existing costumes. Okay? And you can even switch it, as we go here. This is costume 1, which is the default. Costume 2 looks like this. So when I run these 2 costumes right next to each other, it would appear to be running. But not the way I do it right here. Okay, so we'll go ahead and see why it is not going to work the way I think it should be working. Hey, there's no animation here. It's always stuck in costume 2. Yep.
It actually is switching, but it's switching too fast.
Because there's no delay. Okay, so I need the delay, wait 0.1 second, to move between these 2. And I need one additional one after that too. In other words, every time I change the costume, I wanted to wait just a little bit so that we can visually see the change of the costume before it changes the costume again or move forward again. So that means we have to go to control again and go to wait 1 second and put one, at the other one. But since we have 2, this time, every time I wait, I only want to wait 1/2 of what I used to wait. Okay. And let's go ahead and run the program again. Oh yeah. Okay. So this is, I know this is kind of lame, it's not a game or anything, but it does show you how you can write a program and debug a program step by step. Okay. It doesn't do what you want it to do. Why is it not doing what you think it should be doing? Then you can change the program accordingly, run it again, and see if your fix is fixing the problem.
So for games, they just put countless. So everything
Sorry?
For games, they just put a lot of scripts to make it do whatever they do.
You just specify basically more complicated logic to do what the game is supposed to do. And you can make very simple games. You can make complicated games. You can make one game to basically navigate, the sprite out of a maze without touching the walls. You can make it as simple as that. You can make it a lot more complicated. If you want to, you can capture the logic of tic-tac-toe and make Scratch play tic-tac-toe with you. That's not going to be very easy, but it's doable. It's just not easy. Okay, tic-tac-toe. I mean, does anyone not know what is tic-tac-toe or how to play that game? Okay, so everybody knows the tic-tac-toe. So that means the logic is already there. It is in your head already. Okay, you already understand how to play and win. At least have a draw with tic-tac-toe. The question is, how do you put that logic into the code in Scratch? That is the difficult part. Okay, and that's what programmers do, because programmers basically take the logic of how we do things and put it into a particular programming language so the computer can now do exactly the same thing. Okay. Are there any questions? Yep, go ahead.
How would we not make him flip?
You have to go to edit the costumes and turn
Rotate.
the second costumes upside down.
Yep.
So that when you point him the other way, it will flip him 180 degrees and he'll be right side up.
Yep.
You can also specify that next to sprite 1, there's a button for that.
Mirror. Is it a mirror?
I don't remember what it was called.
Okay, if we go back to looks.
You can do that, or you can set it where at the top next under file, where it has not under the tab, but underneath it physically. Where it has
Okay. Can rotate. Only face. Aha. Okay. So this time, we wanted to be the other one. Okay, so first of all, we have to rotate this guy first so that it is in the right orientation. And let's see.
You can drag and drop the purple line on the sprite as well.
Yep. Or we can do this. and then we can say that this will not rotate and just just change the mirror image. Instead of rotating 180 degrees, it will just become the mirror image of what it used to be. So that's the other way to do it, just like that. And now we can run the program again and see if that fixes the problem. Cool. So do we have any questions at this point? No questions? Okay. Let me show you some, a game that I can put together like in a few minutes, okay? Okay, so we'll stop this program, and then we'll go to the stage itself. The stage itself is kind of interesting because you can change the background. Okay, the background is entirely up to you to decide. You can use the plain background the way it is. You can have your sprite to draw the background. Remember the pen down, pen up in the construct? You can put a pen down on one of the sprites and have the sprite to automatically draw whatever you wanted to draw, on the background. Or you can just import an image. Or you can use, select the paint option, and you can paint the background on the fly just using the Scratch program itself. So I will select that option, and you can see that Scratch has its own paint editor, which is a really primitive paint program. It doesn't quite do what the GIMP or Photoshop can do, but for the most part, it's fine. Okay, it's not a problem. So in this case, I just want to draw a maze of sorts. Okay, so I would draw stuff like this, and I have to make sure that there's enough path for the sprite to get through. Okay, so the whole idea is I want to use my mouse to direct the sprite to navigate through this thing without touching the black line. Okay, that's the objective of the game. And if you want to, you can time it too. Okay, so whoever can get this done in the shortest amount of time wins. Okay, but I just want to make it really simple. And the destination, or the final destination here, I can use another color. Let's say we can use, let's pick just bright red here for the finish line. And you can see that I'm not even using a really straight line. It's fine, it's not a problem. Because all I need to do is to detect whether the sprite is touching red or not. That's all I needed to do. And that's it. Okay, I click OK, and now that becomes my background. Okay, my stage is now this little bitmap. I just have to make sure that there's enough room. Aha, okay, so this sprite is not going to be able to fit through. That's not a problem. I can always change the size of the sprite. Okay. If there are no questions about this program, I'm just going to change the program. I'm going to toss this one away and change the program. Do you guys want me to save it? No, not particularly. Okay, well, it's already on in the video clip. So if you want it, you can always watch the video clip again. So I'm tossing this entire program away and start all over again. So this time, the first thing I want to do is to go to looks. And I want to change the size of the sprite to a different size, because I know this sprite is too big to fit through this part of the maze, and well, it barely fits through that. So it looks like if I decrease the size by 50%, it should have way more than space to get through the entire maze. So what I would do is I would change the size of the sprite by 50% of the original size. And just to be sure, we can always change size by, okay, I think that should do it. And this program will terminate based on one of two reasons. One, if the sprite touches anything that is black, I would just say, we touched the edge of the maze, and game over. On the other hand, if the sprite can touch the red finish line, then you finish the task without any problems. So I want the exit condition to be it touches either the black, anything that's black, or it touches anything that is red. Is that doing okay so far? Okay. And I want this to be a loop that basically keeps looping until one of those two conditions is true. So that means I have to go back to control, because control specifies the logic of the program. And once again, I will have repeat until. And this time the condition is going to be a or. Okay? Because when you say or A or B, it means the entire thing can be true if at least one of A and B is true. If I say A and B, that means A and B can only be true if both A and B are true. In this case, I only want an or because if it touches red, we want to get out of the loop. If it touches black, I also wanted to get out of the loop. So that's why we need an or in this case. Or is an operator. It is a Boolean operator, which means both sides of the or have to be Boolean. They can either be true or false. Then we go to sensing, because that's how we can specify touching the color. Okay, so we have touching color on one, and then we have touching color on the other one. And the program doesn't have enough space right now. So let me try again.
If you grab the corner, it makes it easier to put it into the spaces.
Oh, right. That makes sense. Okay, so this one, when I specify the color, it gives me a little eyedropper, so I can sample the color on the screen. So I can sample the black, and next I can sample the red. Oops, there we go. So this comes in pretty handy because I don't really have to remember which color I had picked, because I can use the eyedropper to say, okay, this color over here. Okay. Now we can say, okay, but what are we going to do inside the loop? Well, what we want to do inside the loop is simply to have the sprite to follow my mouse pointer and move very slowly at first, in the direction of the mouse pointer. So this way, my mouse pointer is nothing more than a guide to the sprite. It will just kind of follow the sprite, follow the mouse pointer at a particular speed. Okay, so we'll go ahead and specify that. Okay, we'll specify something simple first. We'll go to motion. We will use one of these features, point in direction, or point towards, in this case, because we want the sprite to point to the mouse pointer. I don't want to do anything else at this point, because I just want to run this program the way it is, and just to see whether it can, in fact, follow the direction. Okay, it's not going to move. I just wanted to see whether it will rotate, according to the direction. But I can't do it right now because it is touching the black already, so the loop will not even execute once because it is already touching black. So in order to do that, I have to put something else in this code. I have to make the sprite to go to a particular position first initially. So I would drag it and put it here first, and then I have to figure out what is the current location.
It's underneath the name sprite on the top.
On top. Oh, right here.
Yeah.
So it is at location -181, -136. We'll just set those numbers here. -181, and we have -136. So I'll just go ahead and, to test whether the program is working the way it should, I move the sprite somewhere else first, because it should move to this location, and then it will follow the direction of the mouse pointer. So I run the program, and, well, it's not rotating because I forgot to reset this part here, so I better go change that. So I will specify go back to can rotate, because in this case, rotating is a good thing. So I will specify it can rotate, and run the program again, and you can see that's how the sprite is following the direction, where the mouse pointer is. Is that okay so far? That's good. Okay, that means the program is working the way it is supposed to. It doesn't move yet because I have not put in the block of